Good evening, everyone. I am Sivakumar. I am part of Tata Consultancy Services. My topic is SafeSense, real-time safety alerts for construction workers. So my co-authors Vishnu Sivan and Grigary Antony. Vishnu Sivan primarily contributed on the front-end building and Grigary contributed on the IoT sensors. So with the introduction, I want to highlight, we all know after three presentations, safety is very important in the construction industry. And though the construction industry contributes to the GDP of the country, almost like 29% of the GDP comes from construction industry. But equally, the fact is that 40% of the death is contributed from the construction industry. So it's very high alarming rate. So the safety is very important. And in this, in enforcing safety, helmet is a very crucial role to enable that it will protect the person from the death. So our risk is how to analyze this and use that helmet to come up the challenges of the construction industry. So before going to the helmet solution, I want to highlight what are the actual challenges in construction industry as considered with a manufacturing industry or other industry. So first point is in construction industry, we use this kind of boards where workers will be knowing that. But this is not highly scalable model. It's very difficult to place such a board and the workers can ignore it. That is the biggest problem. The second one is we are talking about the ergonomics and work nature. It requires, if you are in a manufacturing industry, you can use a tab or mobile phone as a enforcement direction to send alerts. But that kind of system is not possible in construction industry because of its nature and the workers. They may be using both the hands. It's not possible for them to use mobile phones. And the third one is about the dynamic nature. We all know in the construction industry, the zone which is safe today may not be safe tomorrow. Similarly, unsafe zone becomes safe zone becomes unsafe. So it's a very dynamic nature. So we are thinking how to solve all these three problems using one solution. That is what we are proposing. So we come up with a solution for using helmet, using IoT sensors, and providing real-time alerts using dynamic alerts to the sensor. But however, apart from these three challenges, we also want to be practical and understand that we need to address four more challenges. The solution should not become highly costly. It has to be cost effective. And we don't want to propose one more helmet system. We want to use, if there is an existing helmet, can I retrofit existing solution, my solution on top of it? And then the third important point is already construction worker is undergoing this heavy work. So how to reduce, we should not cause additional disturbance to him. That's the third point. And this alert should become remote. That is like using internet, whether I can send from anywhere, I can send the alert. These are the four additional points in addition to my earlier three challenges. So that's what we are trying to address. So the idea is simple. We want to put a small sensor in the helmet and then provide that alert system without affecting, put a small sensor LED so that we will be able to understand what kind of problem is undergoing. That is, whenever is going inside the unsafe zone, we will alert him putting a red signal there. Intuitively, we are putting a small LED panel so that it will not affect his work. So this is the solution we are putting. So before we start work, we want to understand how this problem or how other industries are using this. If you see, many industries try to use this kind of thing, and especially they are using high-end systems like there are smart glasses and other kind of solutions. But that kind of solution is not really possible in the construction industry. For instance, this kind of solution they are putting in the smart glasses, which is not highly viable and scalable considering the scale of the construction industry. So we have done some of the analysis. There are some RFID based analysis and also BLE based things, and then this personal proximity warning. So we have done a deep research and then found only these three mechanisms are available to alert the workers, which is not possible for the construction industry. That's why we come up with this specific solution, whether we can use simple four techniques. First one is using Bluetooth. Now, after Bluetooth, low energy, that energy consumption is also low, and they become cheaper. And another important aspect is whenever we are talking about IoT, security is very important. Otherwise, anyone can hack the system. So we also made a specific mission address. A MAC address will be given to each helmet so that it is security proven. And the third aspect is they should not add workload to the safety manager. So we created a web UI so that anywhere in the location map, he will be able to find and announce the safety zone, unsafe zone easily. So that is the fourth one. And this is about informing to the worker without affecting his usual work. That is the fourth step. So by combining all these four things, we want to give the solution. That's what the basic solution. This is the architecture, the setup, how we have done. You take this kind of simple helmet and house a small microcontroller and a sensor and LED panel. So this is the experimentation setup, and this is how the safety manager, when he says the system, if there are multiple zones, he will be able to mark any zone as unsafe zone. And then the architecture is whenever the worker is entering that zone, this Bluetooth beacon will get the transmitter signal and it will turn into red. The same, similarly, the safety manager can turn it to green whenever the situation changes. So that's the overall architecture. And this is again clearly explaining how does it works. That is, we install transmitters in multiple places of the construction site. The construction site, we will install different sensors, transmitters, and this helmet will be having a receiver. So whenever a worker goes inside that region, that transmitter will get that signal, and whatever is safety manager assigned to that zone, that specific color will be assigned to that helmet LED. So this is how it works. Since he is able to identify and this alert is received to the helmet, that shows what is the kind of signal. So in addition to that, we also added a small buzzer. So these are the four components. Again, there is a transmitter, receiver, and there is an internet cloud where the MAC address validation happens. So it is a security proven architecture as well. And we are using addressable LED. And we have, based on this result, we have done some of the analysis, and the results we are putting in two different ways. One is from the safety manager aspect. He is now able to set the zone easily and quickly and correctly to inform. And he will be able to alert individual because each worker can be identified by a specific MAC ID. That is, in the same zone, I can send a specific alert to a specific individual so that he will be able to understand. And third one is he will be able to monitor the battery status. One of the biggest problem of this kind of solution is the battery can get drained. If that entire solution will fail. So we have sent this alert threshold limit. Whenever battery is not charged, again, manager will get alert so that you will be able to talk to them. And from the worker side also, we observed a lot of results, which is very positive and encouraging. First one is their work is not affected. We have done in a lab setup our experiment and understood and asked the query-based response and found that it is not disturbing his work. The second aspect is whether it is having some ergonomic load, whether the load increased some pressure, that we analyzed and found that it is not causing because it is less than 200 grams. And again, he can charge it easily. The power to charge is simple. Just like any mobile phone, he can charge this battery. And even one charge will work for 5 hours. So these are the results we have found out, and automatically you will be able to get this solution. So this is a summary. We are able to use a Bluetooth BLE powered smart helmet, ergonomically designed, cost effective, and dynamically message can be sent. And there are some limitations. One is it is a privacy concern is there because it can become a monitoring each and every worker. That is one problem. Second one is the battery management. That is the second challenge. And the third one is we have to install so many transmitters across the site, which will be a very difficult task. And the fourth one is, again, we are talking about construction safety, and we are introducing one more safety problem to the worker by introducing a SAR, which is a specific absorption rate, because he has to wear all the time. There will be so much of Bluetooth waves going around. So these are some of the limitations, but considering the advantages, this is somewhat better. That's where we want to do the future work, addressing all these problems and bring the efficient solution. So that's the solution, but I thought of This is the solution we brought in the lab setup. I thought there is a hackathon, so I want to present it, but anyway, we'll just show you here. So since the router is not there, it is not connected. If the router is there, it will connect the position. And whenever you are going to the next region, you will be able to see the color changes. It is trying to connect now. And this will be inserted into this. I am yet to finish this path. If you put like this, and then you can put inside so that it will not disturb the worker. Just put like that. So it will come like this, and it will be coming like this so that you will be able to see without affecting his work. We created a small thing here, that way it will. Thank you.
Cool.